So picture this. It's the very first day of a brand new, incredibly complex AI software project. Your team has agreed on the product vision, the energy in the workspace is buzzing, and everyone is just itching to crack open their laptops and start writing code. But wait a second. How do professional engineers actually tackle day one of a complex project? Well, they definitely don't just start building blindly. Instead, they use a really clever, structured approach to avoid the chaos of random feature creation. In today's explainer, we're diving into exactly how they do this by combining two powerful architectural concepts, the walking skeleton and tracer bullet development. Basically, we're going to learn how to properly lay down the train tracks before we ever attempt to run a high-speed train.
Right off the bat, before we let ourselves get distracted by exciting new features or beautiful interfaces, we have to stop and ask one profoundly important question. What do we need to prove before everything else becomes worth building? Honestly, that single question changes the entire development process. It forces us to shift our focus away from what's simply fun to build and look right at what actually reduces our engineering risk.
Here is our blueprint for today's explainer. We'll hit the day one dilemma, laying the train tracks, running the first train, observing reality, common engineering failures, and finally, the continuous learning process.
Let's kick things off with Section 1, the Day 1 Dilemma, and avoiding the feature trap.
We've all felt that exact rush on the first day of a project, right? Ideas are bouncing off the walls and everyone just wants to code up a storm. The temptations are literally everywhere. Should we build authentication first? Or maybe that slick AI chat interface? What about a gorgeous reporting dashboard or user management? You see, amateurs default to building these easy, comfortable features first because, well, it feels incredibly productive. But that is exactly the trap we have to avoid. Building a beautiful dashboard on day one doesn't actually prove that your AI model can successfully talk to your database.
That brings us to Section 2, laying the train tracks, building the foundation.
If we want to build this the right way, we first have to map out our system boundaries and lay down a continuous line of track from start to finish, completely ignoring any shiny features for a minute. And this introduces our core concept, the walking skeleton. It's the absolutely smallest possible version of an architecture where every major layer exists and communicates. It validates end-to-end connectivity without any complex functionality. Think of it like this. You are simply proving that your train tracks actually connect point A to point B. It is not about building some polished, multi-million-dollar train station with cafes and waiting rooms. It's strictly about making sure that foundational path is there.
So how does this actually look? Well, you build it layer by layer. Step 1, you deploy the front end. Step 2, you connect it securely to the back end. Step 3, you link that down to the database. And finally, Step 4, you just return a simple hello world message back to the screen. Do you notice what's totally missing here? There is absolutely zero business logic, no authentication, no customer accounts, and absolutely no AI reasoning. It is just a successful running deployment. But it is incredibly powerful because it proves that requests reach every layer, your deployments actually work, and errors can be observed. Boom! Our structural tracks are officially laid.
Moving on to Section 3, running the first train, or tracer bullet development.
Okay, so once our structural tracks are laid and verified, it's time to put them under some real technical pressure. We do this by firing a tracer bullet. Now, what is that? It's a single, meaningful workflow built end-to-end through the existing architecture to produce real evidence and validate technical uncertainty. Fundamentally, a tracer bullet is an engineering experiment designed for maximum learning. We are running one single, carefully aimed test train right down our newly laid tracks to see exactly how it handles a real-world scenario. But here's the catch. Which train do we run first? Instead of asking what feature is the most exciting to show off to marketing, we have to ask, which workflow contains the greatest technical uncertainty? We need to sit down in our workspace and honestly figure out which integration worries us the most, which AI behavior is just totally unpredictable. Is there an external service that might randomly fail, or what core assumption would just completely invalidate this entire project if it turns out to be wrong? Whatever that high-risk workflow is, that becomes our very first tracer bullet.
The absolute crucial point here is focus. Your engineering effort must strictly follow uncertainty, not some massive feature list. We build one single path that crosses every important boundary for maximum learning. If we're building an AI support platform, maybe that's just the core refund request flow and nothing else. And look at what we are strictly avoiding at this stage. No analytics, no user settings, no reports, no notifications, no multiple workflows. Just one path, one experiment.
Next up is Section 4, observing reality and adjusting. Let reality be your teacher.
So we've run our test workflow. Now what? We don't just high-five and celebrate that the code compiled. We have to closely observe the journey. What assumptions failed? What data formats didn't match? Were there any crazy latencies that surprised us? Generally, you're going to see one of 4 outcomes. If everything works smoothly, great, you continue to the next uncertainty. If it mostly works but needs a little help, you adjust, maybe tweak your AI prompts or your database schema. But listen closely to this one, replace. If a major technical assumption utterly failed, you change the model or the architecture right now. Seriously, doing it today is far, far cheaper than finding out 6 months down the line. And lastly, investigate, which happens when your experiment actually creates a brand new technical question that needs more evidence.
All right, Section 5, Common Engineering Failures, or how we end up derailing the train.
You know, even with a beautiful, logical framework like this, teams can still completely derail if they fall into a few common anti-patterns. Sometimes, without realizing it, the walking skeleton accidentally becomes half the product, totally losing that required simplicity. Or, teams get lazy and skip important architectural layers, which means the skeleton doesn't actually represent reality at all. A really common one is when the tracer bullet tests a safe, easy workflow instead of the riskiest one. That just gives the team false confidence. Sometimes the team rushes to add new features before they even review the feedback from their tests. And perhaps the most fatal error of them all, building only one single tracer bullet. If you skip layers or only fire one bullet, you're literally killing the continuous feedback loop that makes this whole system work.
Which brings us nicely to our final section, Section 6, the continuous learning process, expanding confidence workflow by workflow.
True professional teams don't just stop after running one test train. They use this framework to continually expand their confidence in the whole system. First, you validate workflow 1, say the AI refund request, your absolute highest risk. Once that's solved and humming along end to end, you move to workflow 2, validating the knowledge base search. Then workflow 3, escalating to human support. And finally, workflow 4, secure file uploads. Do you see the pattern? Each successive workflow systematically validates another layer of technical uncertainty. This lets the project grow securely through validated real-world learning, rather than unchecked, optimistic assumptions.
So, to pull it all together, the walking skeleton creates the stage just once, while tracer bullets keep testing the performance continuously. Think of it like this. Your foundational train tracks are laid down once and gradually improved upon, but you are constantly running new test trains down the line to evaluate new routes and push the absolute limits of the system. Together, they take risky, unpredictable software development and transform it into a highly reliable, continuous learning process.
If there is one massive paradigm shift you take away from this explainer today, let it be this. Don't let your roadmap decide what you build next. Let your greatest remaining uncertainty decide. Build the absolutely smallest system that can support learning and let every single tracer bullet make your next engineering decision a little smarter than the last. So, I'll leave you with this question for your current project. Are you comfortably building what's easy, or are you actually building what reduces your risk?